I meant 5. So this is not a 3, it's 5. First thing, we're gonna go through those steps that we talked about yesterday. So let's revisit the steps really quick. Our steps are: 1, find your horizontal / oblique asymptote. 2, factor your numerator and denominator. 3, find your holes and vertical asymptotes. 4, sketch the asymptotes. 5, you're going to find points to the left and to the right of the asymptote and plot them. Why do you need to do that? Because you need to know what is your function doing around the asymptote, okay? And it's user's choice. 6, find the domain and range if asked, okay? All right, so those are the steps we're going to follow. So we're going to start with step 1. And what was step 1 again? Find the horizontal. To find your horizontal or slant, it depends on the degree of your numerator and the degree of your denominator. The degree of my numerator is 1. The degree of my denominator is 2. So the numerator is less than the denominator, which means what? Difficulties. Here we go. So n is less than d, which means that there is a horizontal asymptote. And what is that horizontal asymptote? Y equals 0. So we do have a horizontal asymptote, and it's at y equals 0. So if you wanted to go ahead and plot that, you could, or you could just wait to the end to plot them all together. Pew, 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 pew. All right. No, they're yesterday's notes, not today's notes. We may. They're in the basket. We're probably not going to make it to them. We're definitely not. But here we go. Next is as to factor. So we're going to factor the numerator and the denominator. To factor the numerator, I'm going to do what? Greatest common factor, the GCF. And the GCF is 5. And that leaves me with x plus 4. Agreed? Now we're going to factor the denominator. What multiplies to give me negative 12, but adds to give me 1. 4 and 3. So we have x plus 4 and x minus 3. Okay? After you factor, you're now going to determine what are your asymptotes and or holes. Okay? So looking here, I have a hole at x plus 4. Why? They cancel each other out. So I have a hole at x equals negative 4. Okay, I have a hole at x equals negative 4. To find the precise location of that hole, I have to substitute negative 4 in. Does that make sense? So on my extra paper, if I had it, I would do f of negative 4 equals 5 times negative 4 plus 20 divided by negative 4 squared minus 4 minus 12. Either way, it's going to equal 0. Why does it equal 0? Because my numerator equals 0. So my hole is at x equals negative 4, comma 0. Okay. Next is vertical asymptote. My vertical asymptote comes from what's not duplicated in my denominator. And what's not duplicated? X minus 3. So when I set x minus 3 equal to 0, that tells me that my vertical asymptote is where? At 3. So I have a hole at negative 4, which is okay anyway, because what's also at 0? An asymptote. I have a vertical asymptote at 3. I'm going to call this 3. Okay. Next, I'm going to find my x and y intercept. Your x-intercepts come from taking your numerator and setting it equal to 0. And it's the original. So if I took 5x plus 20 and set it equal to 0, what do I get? I get negative 4. And it can't be a negative 4 because negative 4 is a what? A hole. So guess what that means? None. There's no x-intercept because it's a hole. No, your x-intercept goes to your affects only your numerator. And the reason being, I can... Okay. Oh my gosh. Something's in my eye. It really hurts, y'all. All right, 0. So we're going to go down to negative 5/3. I'm going to put it there. And we're going to determine what is happening around our asymptotes. So if I choose a point to the left of 3, what point would be a good point to plug in? To the left of 3? Oh. I was like, okay. The other left, yes. I can plug in, we're going to do 2. Is that what we're doing? F of 2. So F of 2, when I plug 2 into the numerator, what's 5 times 2? What's 10 plus 20? 30. And the denominator, what's 2 squared? What's 4 plus 2? What's 6 minus 12? Negative 6. So what is 30 divided by negative 6? Negative 5. So at 2, it is going down to negative 5. So that tells me that my graph is doing this and leading up to my asymptote way better than what I thought. That's what's happening on the left-hand side. On the right-hand side, I'm going to choose another value. What value do we want on the right-hand side? 4. So we're going to do F of 4. Same thing. You're plugging in. 5 times 4 is 20. 20 plus 20 is 40. 4 squared is 16 plus 4. 20 minus 12. And 40 divided by 8 is 5. So on this side at 4, it's going up to 5. So that means that I have to make sure that the graph is somehow going to curve through that. That's what the 5th step is telling you to do. Use values around your asymptote to determine the behavior of the graph. All right, my domain. What can it's all real numbers, but x can't equal what? And what? Negative 4. X cannot equal negative 4 or 3. Everything else is free game. Yeah. Well, no. I don't think it's gonna. Like, let's do negative 5 and see. So we plugged in negative 5. That's gonna give me negative 25 plus 20 is negative 5. 25 minus 5 is 20. 20 minus 12 is 8. Negative 5 is still below. To test Daniel's theory of does it cross at the 4 or not. It really doesn't matter if there's a hole at negative 4, 0, because there's a whole asymptote there anyway. So it wouldn't even work. It's just saying that if there was an asymptote, if there was an x-intercept, this is where it would be. But for double reasons, it doesn't exist. Yeah. Which part? All of it. Tell me. I mean, there's 6 different steps. So you gotta tell me what step. I understand. Okay. I tried to put a lot of examples. All right. This is an example of a fully factored polynomial irrational. And so same things. You're going to determine whether it has a horizontal or slant or neither. So degree of the numerator would be 3. The degree of the denominator would also be 3. So the degree of the numerator equals the degree of denominator. What does that mean? You have a horizontal asymptote, right? And it depends on the leading coefficient. I don't have to unfactor it. I can just multiply. What's x times x times x? That's going to be x to the 3rd. 1x to the 3rd, right? So there's no numbers, no coefficients that I'm multiplying it by. Okay, same thing in the denominator. What's 1x times 1x squared? Why is it squared? Because it would be 2. It's still 1. So therefore, my horizontal asymptote is at 1. A little sketch of it already. So at y equals 1, there's an asymptote. All right, next is to factor. Oh my gosh, it's already factored. Yay. After that is to identify, are there any holes? Is there anything to be eliminated? No, so that means I only have vertical asymptotes. Where are my vertical asymptotes? Remember, you set the denominator equal to 0. So where are my vertical asymptotes? I heard x equals 0 and x equals 4. Denominator equal to 0.
That's a long day.
You were just ahead. I said vertical asymptote. All right, x-intercept. X-intercept means that we're setting our numerator equal to 0. And if I set my numerator equal to 0, what are my x-intercepts? There we go. 1, -2, and 3. Agreed? Next is my y-intercept. My y-intercept, I can't plug it into the original, so I have to plug in x equals 0 and evaluate. So we're looking for f of 0. So 0 minus 1 is -1. 0 plus 2 is 0 minus 3 is over 0. And it really doesn't matter at the bottom because it's all going to do what? So I have a 0 in the denominator. A 0 in the denominator means that it does not exist because it's undefined. Remember, it is okay for 0 to be in the numerator, but it is a no-go for 0 to be in the denominator. So there is not a y-intercept. Which also makes sense because what happens at x equals 0? What do I have? Is a vertical asymptote. So of course I don't have a y-intercept. I can't touch the y-axis. So I have my vertical asymptote at x equals 0, and I have another vertical asymptote at x equals 4. Now I have to determine the behavior around it. Let me finish plotting my points. So at -2, I'm at 0. Call you -2. At 1, I'm at 0. And at 3, I'm at 0. So we're going to determine the behavior. On this side, it's fairly easy to see what our behavior is doing and what's happening here. I have to go through 0, so I'm going to come through. Okay, the middle is where I'm lost. The middle, how I'm going to go from starting my function here and going here. What am I doing? Well, we're going to have to find the value of 2. What's happening in the middle of these two numbers? Is it above or below? So we're going to find f of 2. What is 2 minus 1? 1. What is 2 plus 2? What is 2 minus 3? And then we have 2. What is 2 minus 4? Squared, 4. My 4's cancel, and I'm left with -1/2. So I know at 2, it goes down here to -1/2. So that's telling me that my graph is trying to go back to positive. It's going to go down. It's going to come back up and then head back to positive. I don't know if y'all posted, but I tried to kind of post why that happens when you have a horizontal asymptote, the occasions that you will cross the horizontal asymptote. And the best thing is that some rational functions, especially ones that we're heading towards negative infinity, they're going to do like a little switcheroo and try to head towards positive infinity. And this is okay as long as the turn comes back. So as long as I'm going to end up heading back to where I was avoiding. And it's only gonna it usually happens when your denominator is greater than your numerator in degrees, in terms of degrees. This one, it came out to be a quadratic because look here, it's a double quadratic, which is usually causes some other things happening. The double factor. Sorry, not a double quadratic, a double factor. Next, gotta figure out what's happening to the left of, not left, what's that direction called? Right, my right, I knew that. To the other left, to the right of 4. So I'm gonna plug in 5, is that okay? I mean, if you wanna plug in something else, go for it, but. All right, what's 5 minus 1? 4. 5 plus 2. 5 minus 3. And then we have 5. And then 5 minus 4 is 1 squared is 1. Yeah, it is. All right, so that is, what is that? 56 over 5? Yeah, 56. Did I make that up? Feels right. 4 times 7 is times 2. 28 is 56. All right, so that means it's gonna be what's 56 divided by 5? 10 and something? No, 10, 11 and 1/5. So we know that it has to be greater than 1. So the graph is doing this. Yes. What made me want to say I want to teach math? My 4th grade math teacher? No. No, that was in 2nd grade. You were doing long divisions, you were going over fractions, you were applying it to word problems. I mean, when you're in 4th grade, you don't think it's easy. So not everyone does. Well, the X is where you used to have a box. So before X's, you just had that box. It was like 4 plus box equals 2 or whatever it said. But they tricked you. You've been doing algebra the entire time. It's just it was a box. Your unknown was a box. You have blanks now. Yeah. All right. So, where are we in life? Our domain now. So our domain is what? It's all real numbers, but X can't equal what? X cannot equal 0 or 4. Yep. Now, could you write out the full thing from -infinity to 0 union 0 to 4 union 4 to infinity? Yes, you want to be formal. But as long as you can tell me that this is my discontinuity, this is where I can't go. These are my boundaries, okay? All right, that's another factored one. But really quick, I want to show you that it's not fully factored because the denominator can be factored and it factors it out to X. What? Okay. Let's keep going then. Are you sure? Okay, so I had 11 and 12, and then someone told me to take away the 11 and 12. You're 6th grade?
No.
No, oh, it was you. Yeah, Tony told me to take 11 and 12 away. Exactly. The degree of the numerator is greater than the degree of the denominator, which means that I have a slant, an improper rational. Yes, good job. Okay, because of that, we have to do long division. So I would have X minus 1, and then I have 3X squared minus 8X plus 5. So I'm going to do it fairly quickly. So we have 3X, then we have 3X squared minus 3X. Change our signs. We have negative 5x plus 5. So we're going to have negative 5. And do I really need to go any further than that? No, this is my slant. So y equals 3x minus 5 is my slant. Okay, next we're going to factor. Again, we're going to use a quick box to factor. And the box is my first term, last term, and last box. And I got to find the magic numbers that goes with this x. So it multiplies to give me 3 times 5, which is 15, but adds to give me negative 8. There we go. We need a negative 5 and a negative 3. Greatest common factor is negative 5. Greatest common factor is 3x. Greatest common factor is x. Greatest common factor is negative 1. So our factors are 3x minus 5 over x minus 1. After I factor, I now determine, do I have a whole? Yes. Where's the whole? X minus 1. So I have a whole at x equals 1. Right? Then we have vertical asymptote. Our vertical asymptote. Is there anything left in the denominator after I eliminate the whole? No. So there is no vertical asymptote. And there's no horizontal asymptote. Okay, your x-intercept comes from setting your numerator equal to 0. So I'm setting each one of these equal to 0. Do I have to worry about setting the whole equal to 0? No, because it's a whole. Doesn't matter. It said 0. But 3x minus 5 set equal to 0 is going to put us at 5 over 3. Good job. Your y-intercept comes from plugging in 0 for your x. If I plug 0 in the original for all of my x, I'm left with 5 over negative 1, which is negative 5. So that's everything I need in order to graph. 3x minus 5 is just going to 5, negative 5, and I'm going to rise 3 and run 1. So it takes me to 2 over 1. I'm going to do my very best to just kind of sketch it out from here. And we're going to pretend that this is a straight line. Yep. It's my slant asymptote. All right, I know that I need to go to 5/3 0. So I need to go through 1 1/3. So roughly here at this guy, I go up 1, 2, 3, and over 1. I didn't go over enough. First, pretend that's that. That's that. 1 1/3 is somewhere in here. I didn't go over. I went over too much. I did my best with what I could. Okay, and then I would graph negative 5, which is already right here. It doesn't work. Why is negative 5 not going to work? Because it's on my what? It's on my asymptote. Right out of time. Sure. Oh, nice.